All right, so now we are going to do something exciting that we've never done before. We're going to start with a circuit we already have and a program we already have, and I'm not going to make you take the circuit apart or erase the program. We're actually going to combine a new circuit with the current circuit we have. So as we go along, I'll kind of point out some info as to how we do that. First thing we always do, of course, is power down the Arduino while we're rewiring things. So unplug to take power off. And what we're going to do is we're going to build next to this circuit on another part of the breadboard our normal LED circuit. So I'm going to start with the LED. I'm going to put it across the breadboard trough, just arbitrarily anywhere. I'm going to take my current limiting resistor and I'm going to use it to make a connection between ground and the bottom leg of the LED. And then, just like before, I'm going to take the top, and actually to test, let's do this. Let's take the top connection, and let's just plug it in temporarily to the power bus to make sure our LED lights up. We'll plug in just to see what happens. It does light up, so we got the LED in the right way. So I'm going to unplug here, and now I'm going to go up to one of my digital pins. And in particular, I want to pick one that has a tilde character so that I can do pulse width modulated analog writes to the LED. I'm going to put it in pin number 3. Now I'll plug back in. And since the program is still there running, if I just hit the serial monitor, yep, there's my potentiometer still working perfectly. Great. So all we're going to do is we're going to take that value, that pot value that we're reading and printing to the serial monitor, and we're also going to use it to illuminate the LED. So first of all, we have to tell the hardware portion of things where the LED is. I think I'll put it before so that they're in numeric order. Constant integer LED is assigned 3 because I'm on pin number 3. And then I need to tell the LED to be an output. So pin mode LED, output. Now notice in the previous video, I never did a pin mode for the inputs. The reason is I was being a little lazy, but the Arduino defaults to all the pins being inputs unless you tell them to be outputs. But it is actually perfectly legal to say, and probably more correct, pin mode pot input. So I have the LED on pin 3. I've set the LED to be an output. All I have to do down here is to, after I write the value of pot value that we read from the pot, use that exact same value to do an analog write to the LED with pot value. So we take the analog value from the pot and store it in memory, pot value. We print it to the serial port, and then we write it to the LED output port. And then we wait 100 milliseconds and loop back and do it again, over and over. So I'll go ahead and upload that. And our LED does light up because, of course, the potentiometer is sitting somewhere that has a value. And when I open it up, there it is. So that's what a 641 looks like. So I'm going to go ahead and turn it all the way to the left. There's 0, and at 0, of course, we're writing a 0 brightness to the LED, so we get nothing. And I'm going to slowly start to bring it up to the right. And notice it gets brighter and brighter and brighter. And everything is wonderful until it goes away. I'm about a quarter of the way in, and it just cut to 0 again. Why? Let me go back and see. Oh, no, there's full on, and then once I get to here, it goes right off. And then what happens is I keep going to the right. It goes from 0, brighter and brighter and brighter, and then it cuts out again. And then it gets brighter and brighter and brighter as I keep turning, and then it cuts out again. So what's happening is this. Remember, the LED wants a value from 0 to 255. But our potentiometer is supplying a value from 0 to 1023. So if I go back to 0, Here's what the LED wants to see. 0, 1, 2, 3, 4, 35, getting closer and closer to 255. 255 is the brightest the LED can be. So remember when we did a 256 and the LED went back to being off because the 256 was the same as 0? That's in the 8-bit world. We're giving it a 10-bit value of 256, somewhere right around here. And at that point, it cuts off. So see there, it's going below and above 256, and we're seeing it flash on and off. So what we have to do is somehow take this 10-bit value that goes from 0 to 1023 and change it proportionally into a value that goes from 0 to 255. And we're going to do it with a function called the map function. It literally remaps one set of values to another. Let's pop over to Chrome and go to arduino.cc. And we'll go to Learning Reference. And here are all the functions with quick reference for all of them. And what we're looking for is the map function. So I just search for map, and here under mathematics is map. When I click on that, here's the manual page for map. So map goes a value from low, from high, too low, too high. So remaps a number from one range to another. That is, a value from low would get mapped to low, from low goes to too low, and a value from high goes to too high. So we're starting the number we're coming from and the number we're going to. All right, so let's give it a try. I'll minimize that for now. So before we send the value out to the LED, let's remap it. So we're going to say pot value is assigned map of something. Well, what are we going to map? First of all, it wants to know what variable you're mapping. We're actually mapping itself. Pot value. Pot value goes from 0 to 1023, but we want it to go from 0 to 255. So this range, 0 becomes 0, 1023 becomes 255. Everything else in between scales proportionally. And we take the potentiometer knob that goes 10-bit 0 to 1023, and we remap it into a value the LED can use that goes from 0 to 255. Let's upload that and see what we get. All right, here's our serial monitor. So we start at 0, and as we increase, remember the serial monitor is showing us the values from the potentiometer, but the LED is going to show us the remapped values. So we start at 0, and as we go up, it gets brighter and brighter and brighter. It does not cut off ever. And when we get all the way up, indeed, we have a full brightness LED that is not cut off. And we've gone from 0 to 1023 on our actual potentiometer values. So the LED is getting an 8-bit value, 256 levels, from a potentiometer that's producing a 10-bit value with 1024 values or levels. This practice of remapping inputs to outputs, rescaling data, is very, very typical with any sort of microcontroller circuit, especially when there's a difference between the binary precision of the input, in this case 10-bit, and the output 8-bit. So learn the map function. It's actually pretty simple once you actually see it. The to and from gets very confusing, but if you think of it with this example, it's pretty easy to follow.